Hello everyone, welcome back to UpSmart IAS classes. This is your Reddy Prakash. So in the previous classes, we have studied many concepts about chemistry. And in this particular class, we will be studying about the structure of atom. Who all the scientists gave what kind of structure of atom, how the understanding of atom evolved, what is the current understanding of an atom, that is how atom represents proton, electron, neutron within it. How are they represented? Okay, which are inside atom, which revolves around the atom. These are the modern structure of atoms. We'll discuss all these things today. Okay, so and one more thing I forgot to mention you, there is a slight mistakes in chapter numbers. If you see, this is chapter number 8. Similarly, there could have been mistakes earlier. This is a serious mistake from my side and from our content manager and editor as well. So kindly forgive us. So apart from this, everything is fine. Only the chapter numbers are mistake. So moving forward, we'll study the structure of atom. So what is an atom? Atom is the smallest particle of an element. We know that. Smallest particle of element. Atoms are the building blocks of matter. That is the smallest particle of elements. Like the cells has nucleus around it. And cell membrane around it. Like the cells have nucleus inside it and cell membrane around it. Atoms also has nucleus. These are the nucleus of atoms inside it. And these are the nucleus. This is the structure of atom. This is the structure of atom. The middle part is nucleus and the rings what we see outside. The rings what we see outside are the shells of an atom. Shells of an atom. So one more thing you have to notice, the nucleus caters both proton and neutron. The nucleus caters proton and neutron inside it. It will house the proton and neutron. And where will the electron be? Electron will revolve around the shells. These are the electrons. Proton and neutron in the nucleus. Shells will house the electrons. So nucleus, rings or shells, electrons, proton, neutrons. This is the structure of atom. Understood? We'll discuss all these things again in detail. I am giving a brief introduction. Next, different elements differ due to difference in their atoms. How do elements differ with each other? I told you, elements are made up of atoms. When the atoms are different, elements become different. And similar atomic numbered atoms come together to form an element. You have this knowledge, right? Now, discovery of subatomic particles. Subatomic particles are proton, electron and neutron. To remember this is an important concept. To remember this, what you have to do is PEN, pen. This is a mnemonic, pen. GTC, pen, GTC. Proton, electron, neutron. G is proton was discovered by Goldstein. Electron was discovered by Thomson. Neutron was discovered by Chadwick. And the year of discovery is also in the chronology. So, leave this table, copy this. PAN. PAN means proton, electron, neutron. GTC means Goldstein, Thomson, Chadwick. The full names are not essential. Thomson, Goldstein and Chadwick is enough. And the years are also not so very essential. It can be asked in few exams, but in UPSC not so very important. But you can remember more or less the decades. 1880s, 1890s, 1930s. That is more than enough. And the chronology might be important. It is in the chronology of PEN only. Easy. This was the discovery of subatomic particles. And the smallest particle of an element is atom. Easy with that? Let's move ahead. So, fundamental particles, those are the PEN. I'll tell you, I already told you, Proton, electron, neutron are the fundamental particles. Proton and neutron is housed in the nucleus. Electron is housed in the shells. This understanding we already have. And proton is charged, electron is charged, neutron is not charged. That means they don't have a charge. Proton's charge is +1. Proton's charge is +1. Electron's charge is -1. Neutron doesn't have a charge. Next, what is the weight, the mass of the proton, electron and neutron? Proton and neutron will have a similar mass inside a nucleus, that is 1 AMU, 1 atomic mass unit, 1 AMU. The value of AMU, just like the value of Avogadro's number, might also be important. The value is, note down this value, 1.66 into 10 power minus 27 kg, kilograms. This is also important. 1.66 into 10 power minus 27 kg. This is 1 atomic mass unit. The mass of electron is very negligible. It is very less. That is how it can revolve around the shells. It can revolve around the shells and it can jump between shells. We'll understand how it jumps between shells in the upcoming slides. Okay, easy with this? Fine. Next, the models of atoms was started from Thomson. Thomson initially gave a atomic model. He gave a picture like this. Is this seeming like a watermelon? A slice of watermelon or a plum cake? Plum cake will house those cherries and choco chips, right? Cherries and choco chips. It is like that only. So it is also called as plum pudding model or watermelon model. What he told is positively charged sphere. This is a positively charged sphere and electrons will be embedded within a positively charged sphere. A sphere of positive nature will be there and within that electrons will be embedded like the watermelon seeds, like a chocolate chips within a plum cake or watermelon seeds inside a slice of watermelon. This was given by Thomson. Thomson gave this model. The postulates was put forward by him are: atom is positively charged sphere. Atom is a positively charged sphere. Next, electrons are embedded in it. In it. Easy, right? Fine. Next, atom is electrically neutral. So positive and negative. So the electricity is neutral. Zero. Positive and negative will make the atom neutral. But the drawback of him was he couldn't explain the arrangement of electrons properly. Today's understanding of electrons is around shells, but he couldn't explain at what places the electrons are, and he couldn't explain why. The why aspect was not given. This was explored by the later scientists. This is a drawback. Next, Rutherford's atomic model. Rutherford gave atomic model. The important thing with him is he used a gold foil. And fluorescent screen. This is a gold foil and this screen is called as fluorescent screen. And he used a alpha particle source. This particular box will be beaming alpha particles. It will release alpha particles towards the gold foil, which is covered by a fluorescent screen. We need not understand the process, how this box works, how this screen works, and how the foil inside it works. All that we have to understand is the elements like alpha particle source and gold foil and the fluorescent screen was used by Rutherford. Rutherford used these things. This is what we should understand. Going beyond this and understanding process makes us scientists, not the officers. Easy? Now understand what should be studied. This is Ratta only. You have to do Ratta. By heart it. Few things has to be by heart it. Now the postulates or the observation by him are alpha particles pass straightly. Most of the alpha particles released from here passed straight. Very few deflected, very few of them deflected. Most of the, like more than 80% or 90%, no need of numbers which I don't know as well. Most of them will pass straight. Very few deflections and very few bounce back. What does that mean? See, you have a mirror. Now you are passing a light. Now you say, if you have mirror at the entire space of where the light passes, then what happens? It should reflect back completely. Now we have mirror only in some part. So only some of the light deflects or reflects, and majority will pass in the straight line. That means most of the atom is empty. Most of the atom doesn't have mirror like things to obstruct the alpha particles. That means most of the atom is empty. You know the reason now? Easy, right? Next, positive charge is concentrated in the nucleus. Just like how I said, in the nucleus scatters protons and neutrons. We also told positive charge is concentrated in the nucleus, that is protons in the nucleus. Next, electrons revolve around the nucleus. He didn't mention the cells, but he only told electrons revolves around the nucleus, but the mention of shells was not given by him. Next, number of electrons is equal to number of protons. This was given by Rutherford. Rutherford gave this thing. He told that P is equals to E. He gave protons is equals to electrons, the number, but he couldn't explain the position of electron. All that he told is it revolves around the nucleus, but the shell concept was not given by him. He also gave the size of atoms and nucleus. Remember the size, 10 power minus 10 meter, 10 power minus 15 meter. Size of the atom and the nucleus. Next is the drawback is he could not explain how an atom comes to stability. You know how an atom comes to stability, right? It comes through chemical bonding. During chemical bonding, atoms lose or gain. That is related to valency. That will lead to stability. The stability concept was not explained by Rutherford. Fine. Next, Bohr's atomic model. The modern atomic model, the electron, the atom, nucleus, and the shells around the nucleus. This is the nucleus catering both proton and neutron, and the shells around it. The shells are named as, you know this, KL, Mn. The maximum amount of electrons in each shell is 2, 8, 18, 32. You know this as well. We discussed earlier. This is useful in the calculation of electronic configuration and valence electrons and valency. All these three are different: electronic configuration, valence electron, and valency, which we already discussed in the previous classes. Fine with this? So the shells, the naming of it, how many electrons caters in each shell, was given by Bohr, right? So his postulates were electrons revolves in a fixed circular orbits. The shells was given by Bohr, not the Rutherford. The implementation over the Rutherford model was given by the Bohr. Next, each orbit has a fixed energy. Each shell has a fixed energy. To fall from the upper shell means losing energy. To go to a higher shell means gaining energy. These concepts we'll discuss. But I am telling, each shell will have a fixed energy. Next, electrons neither gain nor lose energy while revolving. Revolving means while the electrons is in a particular shell, it will neither gain or lose energy. But when it jumps over the shells, it will gain or lose energy. Next, these orbits are called as stationary energy levels because each orbit will have a particular energy, and electrons revolve around it without losing energy. Those are called as stationary. Stationary means same energy levels. Easy, right? We'll move ahead. Fine. Next, excitation and de-excitation of electrons. Excitation and de-excitation of electrons. I told you when, one second, I told you when, see, if this particular electron has to move to higher level, then this is called as excitation. When the electron from here has to move to a lower level, de-excitation. Excitation and de-excitation. Now you understood the concept of excitation and de-excitation, which we will discuss again now. Okay, all this is so that you don't get confused. I am repeating the confusing elements number of times, though it is boring. I deliberately repeat them. Excitation and de-excitation. Excitation means electrons gains energy, jumps to higher orbit, which I already told you. The reverse is de-excitation. Easy. See, excitation, it is getting excited. De-excitation is, it is losing its excitement. It is coming down. Easy concept, right? Next, this we already know. Maximum capacity of each shell. Maximum capacity of each shell. But rules are outermost shell can have a maximum of 8 electrons. If the shell is outermost, maximum it can have is 8 electrons. See. And electrons are filled from inner to outside. We know this as well. We calculated valency. At that time I explained you. The electrons are filled from inner to outside, and the outermost shell can have is maximum 8. And again the shells continue. At that time it will start again. Next is configuration, element and its electronic configuration. Element and its electronic configuration. Electronic configuration means how the shells are filled. See, K, L, M, N, K, L, M, N, right? These are the shells. See, if it is hydrogen, hydrogen has only one electron. One electron means the configuration will be only one. Helium has how many? Helium has 2 electrons. Helium has 2 electrons means the configuration capacity of K is 2. It will fill 2. Next is lithium. Lithium has 3 electrons. 3 electrons, right? The configuration 2 will be in the K, 1 will be in the L. So it is 2, 1. Next is similarly beryllium. It has 4 electrons. 2 will be in the K, 2 will be in the L. L can cater the maximum of 8 electrons. Next is boron. Boron, 2 will be in the K, 3 in the L. Carbon, 6 is the electrons, 4 will be in the L. Next, nitrogen 5, oxygen 6, fluorine 7, neon 8. Maximum are filled. This is highly stable. They don't react. These are part of what kind of group? This is group number 18. Group number 18 is called as, comment it down. I have told you a number of times. Next, sodium. Sodium, it is 11, 281. This is easy, right? It continues. Electronic configuration. Next is noble gases. Noble gases or inert gases, group number 18. Inert because they don't react with any other. Why they don't react? Their valency is already in a very good stable configuration. See, helium completely filled in the outer shell, that is the K shell. Neon completely filled in the L shell, that is 8, maximum is 8. Next, argon completely filled in the K, L, M. I told you M, though it has a capacity, to cater 18 electrons, the outermost shell of any element can cater a maximum is 8. 8 means 288. It is still stable. That is how it is noble gas, inert gas. Next is valency. Valency is combining capacity of atom. Combining capacity of atom. I told you valency is different from valent electrons and electronic configuration. Valent electrons, here is 2, here is 8, here is 8. This is the last number of electronic configuration is called as valent electrons. How many electrons will be there? Those are called as valent electrons. Then what is valency, sir? Valency means combining capacity of an atom. How this happens? See now. Hydrogen has configuration of 1. See, if it is configuration, the configuration is 1. I'll also keep configuration. Configuration of oxygen. What is this? Oxygen. Configuration of oxygen. No. Configuration of oxygen, right? Oxygen has how many number of electrons? 8 number of electrons. So configuration is 2 and 6. Next, nitrogen. What is the configuration of nitrogen? Nitrogen has how many? 2 and 5, right? Carbon has configuration of 2 and 4. Sodium and so on. Okay. Now, that is the configuration. This is the valency. Why the difference, sir? See, to get the valency, the outermost shell should cater the maximum amount of electrons. Now, the outermost shell should cater 2. That is K. It is K. The outermost shell in hydrogen is K. It should cater 2. Hydrogen gains stability by either losing 1 electron or gaining 1 electron. Both will make it 0 or 2. So the valency is 1. Oxygen, the outermost shell is K. The outermost shell is K. For K to become stable, it should either be 0 or 8. Now it has 6 electrons. To lose 6 electrons is difficult from gaining 2 electrons. So it will gain 2 electrons easily, then lose 6 electrons. So the valency is 2. Similarly with nitrogen, the outermost shell, that is the K shell, has 5 electrons. The configuration is 5 in the outermost shell, that is the K shell. To lose 5 electrons is difficult, then to gain 3 electrons. So the valency is 3. Understood with the concept of valency and electronic configuration? Easy, right? Fine. Next, covalency. Now valency we have understood, sir. What is covalency? Covalency means co means together. Co means company. Company means together. Number of electrons shared to attain stable configuration. The number of electrons you share it with another element to attain a stable configuration. A stability is called as covalency. Covalency, right? See, carbon has 2 and 4. It should share 4. So covalency is 4. Covalent. I told covalent. We discussed covalent concept, right? Covalent. Carbon is an example for covalent. This concept is already completed. I am just giving a brief nature of it. Fine with that. Next is electrovalency. The number of electrons lost or gained is called as electrovalency. It is represented in positive or negative. It is more or less same as valency, but positive and negative charge is attached to it. Fine with that. Next is representation of an atom. See, this is an atom. 3517 Cl. 3517 Cl. Cl is chlorine. Then 35 becomes mass number. 17 becomes atomic number. 35 is the mass number of chlorine. If X is chlorine, 35 becomes the mass number. 17 becomes the atomic number. 17 becomes the atomic number. Next, X becomes the symbol which is already known. Now a concept is mass number is protons plus neutrons. Protons plus neutrons. I already told you the mass of electrons is almost negligible. We don't count the mass of electrons because the mass of electrons is almost nil. It is almost 0. So to get the mass of an atom, what we count is protons and neutrons, which is placed in the nucleus. Now we understood why the mass of atom is counted only as a summation of proton and neutron, not electron. I will not forget this again, right? Protons plus neutrons gives rise to mass number, not electrons, because it is almost 0. Next, what is atomic number? Atomic number is equals to protons plus electrons. Protons plus electrons is equals to atomic number. Neutral. So the protons plus electrons, the atomic number here is 17. I mean, protons is equals to neutrons. We understood that. Proton is equals to electron. We studied this earlier. The number of electrons determines the atomic number, and it is equal to electrons. Now, if you apply this concept here, what we have is 35 as the mass, 17 as the number of electrons. Now, if a problem is asked to determine the number of neutrons, how will you solve it? See, I'll tell you. I'll take a whiteboard now. Let me take a whiteboard. We have chlorine. We have mass as 35, right? And we have the atomic number as 17. Now the question is number of neutrons is equals to how many? What are the number of neutrons? How will you solve this now? You have the mass number, you have the atomic number. How will you solve this now? Let us do now. Fine. I told you mass number is equals to protons plus neutrons. Protons plus neutron gives rise to mass number. That is m, that is equals to 35. Easy with this. We know this concept now. And atomic number is equals to 17. That is equals to protons or neutrons. Now you substitute this proton as 17. What you get the number of n as 35 minus 17 is equals to 18. Easy with this. This is the way you can calculate number of protons, electrons and neutrons. Easy. We'll go ahead. Next, isotopes and radioactive isotopes. Isotopes means those elements which have same atomic number, different mass numbers. Means if this is there, this will be different, this will be same. See here, this is the wrong expression. H1 this is the correct. This is correct now. See, the mass is represented above H1, H2, H3. The mass is different now, different mass. But atomic number of hydrogen is always 1. Only one electron will have in hydrogen. It is always 1. It will be 1 H1, 1 2 H1, 3 H1. These are the isotopes of hydrogen. Properties of isotopes are same chemical properties. Chemical properties will be same because the mass is same. Different physical properties, the way we look, chemical properties are same because the atomic number is same, the number of electrons are same. chemical reaction depends on electrons, so chemical properties are same. Physical properties depend on the mass, the weight, so the physical property is different. Sorry, see, I am only getting confused. So will you not get confused in the examination? You will. So what you should do? Focus, think, revise, apply it on the paper. Okay, next, radioactive isotopes. These are few radioactive isotopes and where they are used. These are important. You can read it by yourself. Carbon 14 in age determination. That is, what is age determination? Called as, in archaeology they use the term to determine the age. What are they called as? Dating methods. Not the dating, not the candlelight dinners. Next, iodine for thyroid, goiter. Next, cobalt 60 for cancer. Uranium means, nuclear fuel. Iran's 60% uranium enrichment of 440 kg. Next are isobars. Don't get confused with isotopes. Isobars means the opposite of isotopes. Same mass number, different atomic numbers. See, mass numbers are same, 40-40. Atomic numbers are different. Those are called as isobars. Easy with that, isobars. Next, these formulas you already know. Only this you have to know is maximum electrons in a shell is 2n square. N is neutrons. Rest all you already know. So with this we complete the chapter of structure of an atom. Structure of an atom as a chapter is completed. In the upcoming class we'll discuss the final chapter, that is metals compared with non-metals, how each of them react with oxides, water and various other elements or compounds. So this will be the last chapter. It will also include metallurgy as a chapter, alloys, etc. So with this we'll wind up chemistry. The next class will be handled by Ashwajit sir. He will be doing physics for you in a very nice manner. He is a great teacher. You have to believe in him. Fine. So thank you. We'll meet in the next class. And this is your Reddy Prakash. Let's stay connected. Subscribe to our channel. Share it with your friends and family. It will be very helpful for us as well. And to join our courses, contact the number displaying below. We will also be providing a daily mentorship and evaluation of your paper 2 classes, and we will also guide in the improvement or daily tracking of paper 1 scores. Okay, thank you so much. Stay connected. Become smart with UpSmart. Fine. Thank you. Bye bye.